Okay, so surface area. All right, what we did previously is we found the volume of revolution, which meant that we took a curve and we revolved it around an axis, and that revolution created a 3D figure, and then we found the volume of that 3D figure, right? And that's where we got the disk method, that's where we got the washer method, all that. Now we're going to do the surface area of revolution, so you can go ahead and just put of revolution. And so the formula is, I was going to say kill that wolf, 2 pi times the integral from a to b of r times the absolute value, the square root of 1 plus f prime of x squared dx. Yes, but if this dies, oh no, it's good. Sometimes it likes to freeze when I try to zoom in or out. Okay. The r is the distance from the curve to the axis of rotation. And it is always in terms of x. So the r is the distance from the curve to the axis of rotation. It is always in terms of x. Yes. And you'll see exactly why in a second. Okay. So we have two ways we can rotate. We can rotate about the x-axis. So let's say we have a curve, and the curve you draw does not matter. Then we're rotating about the x-axis, right? So we're rotating that way. So the radius would be this line, right? You guys see how each of those would be a radii? Okay. Now that radius is whatever the y-coordinate is, but the y-coordinate can be written as a function of x. Does that make sense? So the function of x is what we're actually going to use there. So if this curve was like negative x cubed plus 2x, blah, 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 that's what we would use. So it's the y-coordinate, but that y-coordinate can be written in terms of x, and so that's how it's in terms of x. If we are rotating about the y-axis, I'm going to go ahead and use basically the same picture. So if we're rotating about the y-axis this time, then the radius of the curve is just whatever the x-coordinate happens to be. And so that one's really easy because it's literally just x. Yeah, so either way, we're in terms of x. But the first way is in terms of y, which is in terms of x. If that makes sense.
Yeah. So we do it in terms of x, which is in terms of y, which is in terms of x.
No. Example 1.
Oh.
Okay. Find the surface area of the solid if you guys did that in college class, the professor would kick you out. The curve f of x equals x to the third from 0 to 1 about the x-axis. So I'm just going to draw, almost got to. We've got a cubic graph. We've got from 0 to 1. This is what we're revolving. It's going to create a 3D shape. And then from that 3D shape, I want to find the surface area. It is revolving about the x-axis, which means that the radius is up and down, which means that it's a y-coordinate, which means that it's a y-coordinate in terms of the function of x, okay? Yep, so I'm going to say radius is top minus bottom, right? Y minus 0, because it goes right up against the x-axis. So that means that radius is x cubed minus 0, so I'm writing it in terms of x. And you might even write that, since these are your notes. We're just taking it, we're putting it in terms of x. And I know that f prime of x is, if f of x is 3x squared, good, because I need that for the formula as well. And so my surface area is going to be 2 pi times the integral from 0 to 1 of x to the third, that's my r.
Square root 1 plus 3x squared squared, which is x to the fourth.
Could we do this by hand, or would we have to do it on a calculator because we don't know how to do it by hand?
No, so we can do this by hand. It would just cancel.
What would cancel?
Well, because u would be 1 plus 9x to the fourth, and then the du would come down to be x cubed.
Yeah. Yeah, so we could do, u substitution is totally valid on this problem. However, we're going to save some time. So go ahead and grab a calculator, plug it in. Probably, because if it's a square root in there, it's probably going to have a decimal answer anyway. So you're not going to avoid probably a decimal by not using the 2 pi. Yeah. So it's a little weird.
What are you talking about? That sounds completely
All right, so we've got that the surface area is 3.563. If we had given units, what would the units for this problem be since we found a surface area? Inches squared, units squared, centimeters squared, something squared. So un squared. Do you have to write that? No, most of the time they don't give you units, so they don't really expect you to write it, but we can. I don't give any craps about significant figures. All right, example 2. Find the area of the surface when y equals x squared from 0 to the square root of 2 is revolved around the y-axis. So we have a parabola. We're only using the right side of it. You can draw the left side, but we're not really going to use it. 0 to square root of 2, something like this. We are revolving it around the y-axis. So for the radius, essentially what we're doing is right minus left. So we can say x minus 0, which is just x. The radius is just x. Y equals x squared, so what's y prime?
2x.
2x, okay, and now we can use the formula. The surface area is 2 pi times the integral
0 to root 2.
0 to root 2 of
X times root 1 plus 2x squared. Yes.
And could we do this one by hand?
Yes.
Yes.
Root 2 would not be great though. Well, I mean, we just need it over here.
So this one actually apparently works out nicely if you don't plug in the pi, and it might be because of the root 2 and all the squaring and what ends up happening. So if you want, yeah, so try so 0 to 2, because I have on my sheet I have an exact answer written down. So it's 2 pi multiplied by 13 over 6, or 13 pi thirds, or a decimal answer would have been fine. Yeah, I don't like that. It's like, I kind of want to do an exact answer, but I also don't. I want the worst of both worlds. Okay, so the formula, I think the hardest part is just getting into more formulas and remembering, like, oh, that's surface area. So we've got arc length, we've got surface area. Maybe I'll write them on the board just so we can keep track of them. But other than that, I think the assignment is relatively easy. What do you guys think? Pretty good? Okay. So it's a book assignment.